we're going to talk about absolute and conditional convergence. These two terms are relevant for series of mixed signs, alternating signs. And the first one says the series summation AK converges absolutely if the sum of the absolute values converges. So this is one example, right? This is one example. Because this guy summation 1 over k squared, which is the absolute value of the negative 1 k to the power, to the power k plus 1 over k squared. So this is the absolute value of that. And this guy converges because it's a p series with p being 2. So therefore, this particular example shows you this series converges absolutely. Okay. Now the second one is if this series converges, but the sum of the absolute value diverges, then we call this series converges conditionally. So this is one example, the alternating harmonic series itself converges, but the absolute value, which is the harmonic series, diverges. So we call this series converges conditionally. So basically, a quick summary says if the series itself converges and sum of the absolute value also converges, we call that as converges absolutely. If the series itself converges but the sum of the absolute value diverges, then we call that as conditionally. Now theorem 8.21, hopefully that's very intuitive to you. So it says if the sum of the absolute value converges, then summation AK converges. So obviously if this guy absolute value, sum of the absolute value converges, it certainly should be greater than or equal to the summation of AK, right? Because summation AK may have some negative sign, the terms with negative sign, so its summation should be less than the summation of absolute value. If so, similarly, because we do know this guy is always greater than this guy, right? So therefore, if this guy diverges, this is even larger, so therefore it must diverge as well. So those are the terms and one theorem. Let's take a look at the following example. You might want to pause the video so that you can try it yourself. So first of all, you can use the alternating series test to test this guy is actually it converges because 1, it is decreasing, right? It's decreasing. Second, the limit of this guy when k is approaching infinity is 0, so therefore itself converges. Okay. But now if you look at its absolute value, so summation absolute value of that, which means just 1 over k to the power 0.01, this guy is p series with p being 0.01, which is less than 1. Therefore its summation absolute value, right? So this guy diverges, and but itself converges. So which you can conclude that this series converges conditionally. Okay, so that's how it works. You check itself whether it converges or diverges, and then you check its absolute value. So now the second one, I'll leave that to you. So the first one, this alternating series converges. You can quickly check two things. One, it's decreasing, second, its limit of the AK is approaching 0, so it's quite obvious actually. So the second part is look at its absolute value, so which means you're gonna look at this guy, right? Okay. Now when we look at this guy, again in class we say we think about the net effect. Usually you don't need to worry about too much on the lower degree term. So in this case, you can mentally think that this is going to be 1 over square root of k squared, which is 1 over k. 1 over k is equivalent to harmonic series which diverges. So mathematically speaking, this is what I will show. I'm going to use this compare with 1 over k, right? And you can show that this limit is 1. Now according to the limits comparison test, this means both this and this converge or diverge at the same time. And because 1 over k, summation 1 over k, this guy is harmonic series, therefore which diverges, therefore this guy diverges. So diverges, right? By limits comparison test. So because it self-converges, but the limit, the absolute sum of the absolute value diverges, you can conclude that this series converges conditionally. Okay. So that's the second one. Now let's take a look at the next one. This is a very good example because here this cosine k, in the previous two examples, the terms, the sign of the terms, they're alternating. If one is the positive, the next one is negative, and then the next one is positive again. So this may or may not be true. Cosine k, it's sometimes positive, sometimes negative, but it doesn't guarantee that the signs are absolutely alternating. So therefore, they will alternate, but may not be a very good pattern. So therefore, this time, certainly the alternating series still work because the sign will alternate, but not necessarily one after the other. Okay, so first of all, we can see that this guy is going to be less than or equal to 1 over k cubed, right? If you compare this term with this term. And this is absolutely, this is P series with P being 3. And this series converges, right? Converges. Therefore, this guy, summation cosine k over k cubed, certainly is less than or equal to summation cosine k cubed, the absolute value, and which is certainly less than or equal to summation 1 of k cubed. Now, because this guy converges, all these must converge. This must converge, this must converge, right? This also converges, and this also converges. And you do see that from here, it self-converges. It's sum of the absolute value converges. Therefore, this is an example of, therefore, the series converges absolutely. Okay. Now, so that's so far we've gone through a couple examples. Shows you that they show you both conditionally and absolutely the convergence. Now, really, that's pretty much it. So, but let's take a look at the next one. Quickly skimming through, you can see that this is approaching 1, the limits. It's not even 0. Then we know that this guy itself is divergence, right? Divergence. So it's not relevant to talk about, it's not convergence, so not relevant to talk about convergence absolutely or conditionally. It's just it self-diverges. So the very last one, so check again, it self-converges. It converges, right? Because of the couple reason. One, it's decreasing. 1 over k squared plus 3, you can check this is really decreasing. Second, and then by the way, in class we mentioned how do we check. You can find the derivative, and then derivative is less than 0, right? That's one way to show it. Secondly, the limit is approaching 0, therefore it converges. If we look at its absolute value, which is this guy, and again, using a quick limits comparison test, you can compare that with 1 over k, and you can see the limit is 1. The limit is approaching 1, okay? Now this is harmonic series. This is the term from harmonic series which diverges. Therefore, you know this guy diverges. Therefore, summation k over k squared plus 3 diverges. So we can conclude that this one it converges conditionally in this case. Right, this is it for the rest of this section that I did not get a chance to cover in class. So this is it.